Hi everyone. In the part 1 and 2, we learned about dry heat and moist heat sterilization types. In this part, we are going to discuss about filtration, one of the type of physical methods of sterilization. Now, let's have a quick review of the physical methods of sterilization. Okay, then we'll go in detail about our filtration. So as we know the definition of the sterilization, it is defined as a complete elimination or killing of all microorganisms, including their spores, and making the materials free from them is going to be called as a sterilization. And as we know, there are two types of sterilization. One is a physical method of sterilization, and then another one is a chemical method of sterilization. And coming to the physical method of sterilization, these are all the types that we are having: sunlight, drying, heat, filtration, and radiation. And we have gone through all these things in the previous part 1 and 2. Okay, there you can have a detail of about all these things. And then now we are going to discuss about filtration in this part, and radiation will be in the next part. Then coming to the chemical method, so these are all the chemicals that we are used in the process of sterilization. Then moving to our physical method of sterilization and overview of it. So here the heat, radiation, and the filtration. The heat is going to be of having the different types, that is dry heat and moist heat. And the dry heat is going to be red heat, flaming, incineration, and hot air oven equipment. We have discussed in detail about it. And then moist heat, here also we are having the different types of the things, that is below 100 degrees, above 100 degrees, and 800 degrees. So we have gone through the autoclave, chindalization, all pasteurization, all these techniques here in the moist heat. So these are the things that we have discussed or learned in the first part and the second part. And coming to the third part, we are going to discuss about the filtration. That is, what are the different types of filters, what is a filtration, everything we are going to discuss. Okay, so let's come to the thing. So filtration. So many of the biological fluids, that is liquids or gases, cannot be sterilized by the application of heat, isn't it? So obviously what should we do? So their sterilization is achieved by a method called as filtration. And how do you do this? The process is called as filtration. So what you are going to use for that filtration technique or nothing but the filter. A filter is a device with pores too small for the passage of microorganisms, but large enough to allow the passage of liquid or gases. So those are being called as filter. It's a kind of sieve that we are using in the filtration of our microorganisms. So okay, so a filter can be of different types. Okay, here you can see the different types of filters, like candle filters, air filters, syringe filters, membrane filters, sinter glass filters, asbestos filters. Like this we are having so many different types of the filters to filter our gas as well as the liquid substances. Then why we are doing this filtration? So the filtration is going to be useful to filter antibiotic solutions, sera, and some sort of carbohydrate solutions, mainly used in the preparation of culture media, vitamins, tissue extracts, etc. So for that, these all substances cannot be sterilized by either applying any heat, either moist heat or dry heat. So obviously what is the other option that we should follow is the filtration. Okay, now coming to the different types of filters that we just see now. Okay, we will discuss few about them. So there are different types of filters, each having its own applications. So majorly filters are going to be classified into two types. One is called as depth filters and the one is called as a membrane filter. So here you can see the pictures, so I'll tell you what all these things. Okay, this is a membrane filter and these two are the examples of depth filters. So here is a Berkey field filters, and these are the siege filters, and these are the sinter glass filters. Okay, and this is the membrane filters example. And now let's see the first one, depth filters, and then we will move to the membrane filters. Okay, depth filters. So what are these depth filters? These are the one of the oldest type of filters. Okay, these are the oldest type of filters, or one of the oldest type of filters. And they are going to consist of overlapping layers of fibrous sheets of papers, asbestos, or glass fibers. The overlapping fibers create random paths through the filter that trap many particles. Okay, so these depth filters are made up of either by diatomaceous earth or unglanced porcelain materials or asbestos and other similar materials. So here you can see the example of this depth filter is a uh, what we call it as a candle filters. Okay, diatomaceous earth filter, Berkey filter, all the things are going to be there. So then here is the asbestos filters and here is the sinter glass filters. So let's see the first one, candle type filters. So as they are looking like a candle, so obviously the name may be given as a candle filters. So examples I told you is the Butterfield earth filters and diatomaceous earth filters. So these are them, Butterfield filters and diatomaceous earth filters. So here are the things. Okay, so these filters, so just I will give a brief note about these filters. So these filters are widely used to filter bacteria and other particles in the liquid, and these types of filters are usually made in the form of a hollow candle. So once upon a time these were used in the filters, names like Ganga water filter, all those things you can see these are candle type of the filters there. Okay, so there we can find about this one. So this is going to have a hollow handle open at one end cemented with a metal nozzle. So here you can observe the liquid to be filtered is either poured into the candle or it is going to be passed through the candle. So that's how this is going to work. And then coming to the porcelain, so I have not given here. Okay, porcelain filters or Chamberlain or Pasteur filters. So these are consisting of a hollow unglazed cylinders. So it may be looking like this, but it is somewhat different. So these filters are mainly, that means porcelain filters are mainly made up of or composed of oxides of silicon, aluminium, potassium and sodium with traces of oxides of ions like calcium and magnesium. The mixture of these all things are commonly called as porcelain. So that's why these filters were named as porcelain filters. And these filters are going to be of various porosity like L1, L2. That is depending upon the size they were named as one, L1, L2, L3, etc. Okay, and then here comes to the Chamberlain Pasteur filter is the best example of this porcelain filters. Then coming to the next type of the filter is asbestos filter. So obviously here you can see the asbestos, and example is the cryosolite made up of magnesium silicate. Okay, so these are made up from, as I told you, cryosolite type asbestos, chemically composed of magnesium silicate is the main composition of it, and this is going to be attached to a vacuum flask. The whole unit is going to be trapped like this, you can see here. Okay, vacuum flask, whole unit is wrapped and autoclaved. And then coming to the last one is sinter glass filter. Okay, so these are made up of finely ground glass which are fused to make particles adhere. They are available with different pore sizes. So we are having the different types of the pores where they are kept and the liquid is going to be passed. Then these are all about the depth filters. So we have seen the four types of the depth filters, that is candle type filters, porcelain filter, asbestos filters, and then coming to the sinter glass filter. Now we'll move on to the next type of the filter, that is membrane filters. Okay, so membrane filters, RANE. Okay, so these are also called as molecular filters or millipore filters, or sometimes these are also called as ultra filters. And these are the most common type of filters for sterilization in the field of microbiology. So obviously culture media components, those are having the heat labile nature, so those can be sterilized by using these membrane filters. And these membrane filters are mainly composed of polymers made up of with a tensile strength such as cellulose acetate, cellulose nitrate, polycarbonate, polyvinylidene fluoride, or other synthetic porous materials. And the pore size may vary from 25 microns to less than 0.025 micrometers. Okay, and these are used to sterilize materials that are readily damaged by heat sterilization. So example, you can have your media, special nutrients and pharmaceutical products such as drugs and vitamins. All those things can be sterilized by using this membrane filters. So these filters remove microorganisms by screening them out, such as sieve separates larger particles from the smaller particles. So how it is going to separate? In the same manner, these filters are going to be used. So here you can see, here is a sterile flask and filter vessel, and in between you are going to have a membrane filter. Okay, look at this picture. So here is a membrane filter. So if this membrane filter was taken out and kept on the medium, you are going to see the microbial growth, and in the microscopic picture you are able to observe them like this. Okay, and this is very useful to sterilize, as I told you, the pharmaceutical products, ophthalmic solutions, culture media, oils, antibiotics, and other heat sensitive solutions. So that's how the membrane filters are going to have a very advanced one when compared to our depth filters, and it is also having more advantages like membrane filters are relatively inexpensive, okay, and they do not clog easily. What is happening in our depth filters, here it is not going to be happen, and these membrane filters can filter large volumes of fluids. So where in the depth filters we can't do it, but here in this one we can do it. And coming to the disadvantages of these membrane filters, many of them allow the viruses and mycoplasma to pass through them. So that is the main disadvantage of it. And even they may absorb some sort of filtrate, okay, and they may introduce the metallic ions into the filtrate. So these are the few drawbacks, but coming to the advantages, majorly it is relatively inexpensive and do not coagulate, and we can filter the large volume of fluids. Okay, so these are all the things that we are going to discuss about the filters, and majorly we are concerned with the filtration of the liquids. Now we are also supposed to have a sterile air, isn't it? So that sterile air is going to be coming with the process called air filtration. So why this air filtration is required? So this air filtration is very important in the burning ward, okay, or in operation theaters. Everything, the air should be in a sterile condition. Not only the equipment or the surroundings or the floor, the air also should be in a sterile condition. So for that reason, the air also should be filtered. So we can't do the heating, or some radiation is also going to be applied, but filtration is also the one of the sterilization method that is mainly used. So let's go in detail about air filtration. So air filtration can be sterilized by filtration method, that is going to be by using surgical masks. Yes, nowadays we are using these masks to prevent the infection from the others, especially the airborne diseases. And then coming to the cotton plugs. So in the microbiology laboratories, if you observe, the test tubes are having some sort of a plugs. Okay, so here it is. So cotton plugs, which will allow the air passage to supply the oxygen to the microbial growth, but at the same time this cotton plug is going to stop the contaminants that are passing through the air into the medium. Okay, then we are going to have a laminar airflow cabinet. So this is a laminar airflow cabinet, so that we will discuss in detail now. Okay, so here some operation theaters, as I told you, some rooms occupied by burn patients receive filtered air to lower the number of airborne microbes. So in that conditions we are going to use this air filtration. Now these laminar airflow cabinets are going to have special type of the filters. So what are those filters? Called as HEPA filters. So these HEPA filters, the full form of HEPA filters is high efficiency particulate air filters. High efficiency particulate air filters, which can remove of 99.97% of the microbes from the air. Okay, and we went with the 0.3 micrometer sized particles. And these HEPA filters not only being used in the laminar airflow cabinets, these are mainly used in the ventilation system of areas such as I told you, operating room and the burning unit. And HEPA filters capture organisms released in the room occupied by the patients with tuberculosis also. As I told you, the airborne disease. Pathogens are also going to be trapped by these HEPA filters. And these HEPA filters are mainly going to be involved or kept in the laminar airflow cabinets, which are being widely used in the cultivation process of microorganisms, all those things in the biological laboratories, especially microbiology laboratory. So let's see the laminar airflow. So here you can see this is the laminar airflow. This is a glass door, and we are having a light visibility, and here you are able to see a tube light. Okay, so this tube light is a UV lamp which will be used to sterilize the internal chamber before the working of this laminar airflow cabinet. Okay, and here you are going to see some sort of a filter will be there, which is having a supply of a filter air to the inside the chamber, and it is going to suck the air from the back, and it is going to push out the sterile air inside, and the one which is going to be coming in the chamber is going to be thrown out. So this is how the laminar airflow is going to be working. Okay, so let's see in detail. The laminar airflow biological safety cabinets are one of the most important air filtration systems. So we can, in a microbiology laboratory, we cannot sterilize the whole room, isn't it? It is a very big task to do that process. So obviously what we are supposed to do is we are going to take an area like this cabinet, such that that area is going to be of a completely sterile in condition. So that sterile condition is very needed for the microbiological cultures, all those things. Okay, a new system used to create a germ free environment or aseptic condition is nothing but our laminar airflow. A parallel flow of sterile air is blown inside the laminar airflow chamber through the HEPA filters. So here you can see. Okay, so you can see the parallel airflow of this germ-free air is going to be flown inside the laminar airflow. It is not allowing the things to come inside. And you are also going to have a the air is freed from infection by passing it through the HEPA efficiency particulate arrestor or air filters. And it employs HEPA filters which remove, as I told you, this much of percentage of the microorganism, which are of even 0.33 micrometers particle in size. Okay, and sterile air is blown at a constant velocity. As I told you, it is going to be supplied with blown with the continuous flow of air, so which is going to expel out the contaminants from the environment. So obviously it is going to maintain the aseptic conditions, and it is used for inoculation and cultivation of microorganisms of the desired in a pure culture without any contamination, as I already told you. And it is fitted with a light or illumination purpose and a UV light for sterilization of aerial environment. So this is what I told you. Here is the light source, and here you are going to see a UV lamp, so which is used to again for the sterilization purpose. And it you are going to sterile this one before performing the experiments. Like the floor of the chamber is wiped with a piece of cotton dipped in the absolute alcohol. So this is the floor, and this whole thing things are going to be removed off, and this floor is going to be cleaned or wiped off with the alcohol or the spirit. Okay, and then you have to dry it, and you have to close it, and then you have to switch on the UV light, everything. So this is all the sterilization process. Okay, then you have to close the doors, and you have to leave it, and then after coming again you have to switch on the UV light, then you have to open the door again, if possible wipe off with the ethyl alcohol or the spirit, wipe off this floor, and then you can keep your sterilized broth cultures or culture media, whatever you want to have it the process here. Okay, so pouring of the medium and inoculating of a given culture are done near the flame at the spirit lamp placed inside the chamber. So here you can see a flame Bunsen burner is there. So we know that inoculation loop have to be sterilized by the red hot sterilization method, and the culture that we are transforming, you have to have the flaming, isn't it, to avoid the contamination. So these are all going to have a combination of sterilization techniques. See here, we are going to have the usage of the UV light, which is a radiation type. And then here we are using a Bunsen burner flame, which is a dry heat sterilization method, isn't it? And we are also using a chemical to wipe off this one, so that comes as a chemical sterilization. And again, we are using the HEPA filters, so which is a filter sterilization. So it's a combination of different types of sterilization that we are performing in the laminar airflow. But majorly the laminar airflow cabinets are meant for air filtration. Okay, so that's how we'll read under this one, under the filtration technique. So these are all the advantages of this airflow cabinets. So biological safety cabinets are one of the most important air filtration systems and generally used for isolation and cultivation of bacteria in aseptic conditions. Then it is used to inoculate the spores of fungi into the medium. And then laminar airflow cabinets are also used in research labs and industrial, such as pharmaceutical industry, when a sterile working surface is needed for conducting assay, preparing media, examining tissue cultures, etc. So these are all the advantages of the laminar airflow. So that's how we finish the type of or different types of filters and the filtration technique. So here in this filtration sterilization, so we have gone through the different types of filters. Okay, so these are all the different types of the filters, and depth filters and membrane filters are mainly used in the liquid filtration, that is liquid sterilization. And coming to the air filters, so here we had gone through about the different types of filters, and then we had gone to mainly about the HEPA filters, where we are using it in the laminar airflow cabinet. And this radiation we will discuss in the next part. Okay, thank you.